So you can see right here that this first option says collision shape. This is really, really important, especially if you want to have detailed physics simulations that are completely realistic and follow the contours of an object. A great example of this is if I add in another mesh. I'll go ahead and add mesh monkey. Now our monkey right here is much more complex than our cube. I'm going to go ahead and scale this platform up so we can see this difference here. Our cube right now has the shape of a convex hull. And basically what that means is it will kind of average out the shape and it'll give us a physics boundary that is in the shape of a convex hull, which is the average of the object. If I click on sphere, you'll notice, it's kind of hard to see, but it is within the object. This is now going to act as a sphere when it falls. In other words, it should be able to roll. And then if we change this type to cylinder, you can kind of see if we go into our X-ray mode here, there's a cylinder within this cube, which means that when this object drops, it will basically be treated as a cylinder and not as a cube. I'll show you the example right here. We'll go ahead and press play. Notice how it falls in a way where it's a cylinder, and I'll prove this by rotating our cylinder here. We should get some rolling action now. Let's go ahead and move this and play this back. Notice how it rolls in a natural way that a cylinder would, but if we go out of X-ray mode, it doesn't really look like it makes sense, right? We have our intersections right here with our cube and our bottom platform. This wouldn't naturally happen, right? And that's why it's important to know that we typically want to choose the shape that is mesh. Mesh means that it will take the shape of the actual object and calculate the realistic physics for that object. A great example of this is if we apply a rigid body to our monkey here, okay, and we go ahead and change this type to box, watch what happens when I drop this on the plane. All right, so you can see that the physics are calculated based on this box that surrounds the monkey. However, if I back this up, okay, and I go ahead and switch box to mesh, you can see that now this orange outline is around the monkey. So watch what happens when I press play now. Notice how it falls naturally and it actually interacts properly with our plane. Let me back that up again so you can see. And if I look, you can see that these touch points right here, where it touches the platform, are actually accurate this time, right? It naturally will hit the platform and fall as if it were a real object in real life. If I wanted it to roll, I could switch this to a sphere, all right, a sphere shape type for collision, and it should roll. Now, this is cool, and there are practical uses for this, but me personally, I'm always going to choose mesh because I'm getting an accurate representation of how this object would actually fall onto our platform. So I'm going to go ahead and switch this back to mesh, and I'll show you one more example. I'm going to Shift D to duplicate this. Let's see what this would look like if we had multiple objects. And notice how they can also interact with each other. They can roll off the platform, but they roll off the platform in a more natural way. There's a ton of other options I want to explore with you guys today. As you can see, we've just discussed the collision shape type, which is super important. You'll notice there's also another drop-down that says surface response. This is also very important and can heavily affect our physics simulation. Now for this purpose, I'm going to be deleting our monkeys, X to delete, and I'm going to go ahead and select our cube, and we're going to focus mainly on this cube because it's going to be a great representation of how friction and bounciness work. So friction is as you would think it was in the real world. If you have a piece of ice sliding on a table, it probably has a low friction. If you have a tire on the ground, right, that friction is going to be higher. So friction acts the same way in Blender as it does in the real world. I'll show you an example. Right now, we're at 0.5 friction. Let's go ahead and play this back. You can see it rolls right off. Now let's go ahead and increase that friction to 1, and let's see what results we get now. Look how much slower it's rolling off. I'm going to go ahead and raise this frame right here so we can see the rest. Notice how slowly it's falling off of this surface. Now, if you want to physically simulate different materials such as rubber, ice, wood, tile, these are the types of things that you can mess with to get a more realistic result. you'll see that we also have this bounciness value, and it's exactly what you think it is. Now, in order to more accurately see how bounciness works in Blender, I've actually added a sphere to our scene with a type shape sphere for the collision, and I've turned our bounciness up to 1.5. Our platform is at a bounciness of 1, and let's go ahead and play this back. Now you can see that we've added a sphere that bounces a little bit. Now, it does eventually slow down as it would in real life, but you can see that if you test different values, such as 2 for a bounciness, and you go back, you'll see how it affects the scene. Now, it's not perfect by any means, but you can add bounciness to things like basketballs, baseballs, soccer balls, and pretty much any sports ball that you would play with. You can add a specific bounciness to that. And there's plenty of other applications for this as well. There's another very important setting that I want to go over with you guys that's called the sensitivity and collision margin. Now, this will make sense in just a moment. I took off the bounciness for our sphere for this demonstration. You can see that if I press play, the ball falls as it should, and it starts to roll along the surface. And you can see that it accurately touches the surface, if we go to our side view, where it should, okay? However, sometimes in physics simulations within Blender, you don't want the object to actually touch the surface accurately. There are practical reasons for this, and I'll show you what that would look like. If we click on our platform, and I'm going to back this up to frame 1, you can see that there is a collision margin checkbox. I'm going to go ahead and select that, and I'm going to go ahead and set the margin to 1. Normally it's at 0 or a very low value. If I press play, you'll notice how our ball still lands, but it sort of floats above the surface in a weird way. That's because our margin, which is the distance between our physics collisions, is now higher. I'll set this to 0.5, and let's see what we get now. You'll see that it's just slightly closer to the surface. Again, there are practical uses for this. For example, if you wanted to do an optical illusion, or maybe you wanted a surface to have some sort of force field or barrier, this could be a visual way to represent that. And again, it still will calculate the physics normally, but just pretend that there is almost a layer that goes around our bottom platform. That is our collision margin, and you can add that to any rigid body object.